Vertex AI Experiments. So as you know by this point, model development takes a lot of iteration. It takes a lot of trying out different model architectures, parameters, hyperparameters, data formats, so on and so forth. So in your first run, maybe you tried one architecture, used one version of your data set, and set some default hyperparameters. You check the performance, you make some notes, and you decide to try a different model next. In the second run, you adjust the architecture, you tweak some hyperparameters, you use a slightly more complex version of the dataset with new features, and then you measure performance again and you compare it with your previous attempt. You repeat this process, adjusting inputs, trying different combinations, observing what changes, and this continues through multiple runs. Some models improve, others don't, and eventually you start to lose track of which changes led to which results, right? So you're essentially creating a lot of different trials, a lot of different intermediary models before you even decide to save multiple models or model versions in a model registry. When you realize how many trial runs it takes to get a good model, some questions arise. How do you keep a record of all of these iterations? And if something worked well, in the past, how do you trace it back to that and reproduce that setup? It's helpful to have a way to track these runs, look back at what you did, what worked, what didn't work, and potentially recreate them where needed. So that's where Vertex AI Experiments comes in. Vertex AI Experiments gives you a lightweight way to track and organize all of your training runs. So each time you try a different setup, maybe you adjust the learning rate or change your data split or test a new architecture, you can log it as a separate experiment run. And you can record data about each run, the parameters used, the model type, the metrics, the data set. So this makes it easier to see what you've tried, compare those runs, and figure out what helped and what didn't. You can also filter, sort, and review past runs without digging through notebooks or saved scripts. And if one of those runs turns out to be promising, you can promote that resulting model directly to the model registry for versioning and potentially deployment. Let's walk through how Vertex AI Experiments connects to the model registry. So on the left side, we're in the development phase here. This is where the experimentation happens with our models. The actual training runs that get logged by Vertex AI Experiments can use either custom training or AutoML. And in practice, most teams use custom training here since it gives more flexibility over model architecture and training loops, and that's kind of the entire point of Vertex AI Experiments, right? To have a lineage of those things and be able to go back and iterate or rerun. So usually custom training and Vertex AI Experiments kind of go hand in hand. But each box here represents a different training run. So we see different learning rates, we see different accuracies, and so you might run dozens of runs like this, really, adjusting parameters, data sets, and architectures as you go. Vertex AI Experiments tracks this all for you. It logs hyperparameters, artifacts, metrics. It helps you compare those runs. And once you've identified a strong candidate, so here, I've highlighted run 4, which looks like it's performed the best, you can promote that model into the model registry on the right. And so now we're in the production phase. This is where the versioning, staging, and deployment come into play. So each version here represents a model that's been promoted from a past experiment. Version 1.0 is archived, 1.1 is staged, 1.2 is the one that's in production, and 1.3 is a candidate model possibly being evaluated before deployment. So the registry makes it easy to roll back, track changes across versions, and compare performance over time. So these kind of go hand in hand, at least once you find a model through experiments that you want to promote. So once a version is selected for serving, it can be deployed to an endpoint, a production endpoint, as a production model. So here we're serving model version 1.2. So the overall flow is iterate and log experiments during development, promote the best runs to the registry, and deploy selected versions into production. Now, I want to harken back to a couple of concepts we talked about when we discussed responsible AI practices. Two ideas that came up in that conversation were reproducibility and traceability. These are especially important when you're experimenting with different model configurations or tuning parameters over time. So let's look at how a tool like Vertex AI Experiments helps with that, right? So toward the top, we have a timeline of training runs. We have a first run that did not perform well. The accuracy was just 0.65. Later runs improved, and the third one showed an accuracy of 0.92, and then the last experiment here reached an accuracy of 0.94. Now, because of Vertex AI Experiments, Experiment 3 has been fully tracked. So have all the others, but let's just look at Experiment 3 as an example. You can see the parameters that were used. You can see the learning rate, the batch size, the number of epochs. You also have details on the data set, including how many samples it contained and even a hash of the file, so you can confirm that it hasn't changed. Just below that, we see the evaluation metrics, the artifacts generated by training, like the model file and the logs. And then at the bottom, you'll notice that it also records environment details. When all of this is captured, it gives you a clear way to go back and to understand exactly how a particular model was produced. So you can produce the results later if needed. You can reproduce the results later if needed. You can compare them to other runs. You can share them with collaborators, team members who want to understand the changes. So how does this relate to reproducibility and traceability? Well, Vertex AI Experiments gives you reproducibility by automatically capturing these parameters, data versions, environment specifications. So you can recreate any model with deterministic results, and that's really helpful. It also provides traceability by maintaining end-to-end experiment lineage, enabling root cause analysis of performance changes and helping with audits. So you can create a complete decision trail from initial data to final deployment. So automatic tracking here ensures that you gain both the ability to recreate what was done and the understanding of why it was done if you need to trace back. Together, these make the process more transparent and more accountable and more trustworthy. So understanding this is important, both in the real world, just using Vertex AI, and for the exam.